All right, in this next unit, we are going to be looking at ionic compounds in the mole. This note packet is going to focus more on your ionic compounds, and we'll get to the mole later in a couple of class periods. Now, when we are looking at ionic compounds, you have to be able to identify them, both their formula and other common examples, such as their names. So first off, we need to talk about what is an ionic compound. So last unit, we looked at covalent compounds. If you had a covalent compound, that was a metal or a nonmetal plus a nonmetal. But here, if we have an ionic compound, they are a little bit different. Your ionic compounds are composed of a metal bonded to a nonmetal. So the first thing you have to do to recognize an ionic compound is look at its formula. If it has a metal and a nonmetal combined together, that is an ionic. If it does not, it's probably covalent. Now, your second thing that we need to know about your ionic compounds is that when you form an ionic bond, that bond between the metal and the nonmetal, the electrons in that bond are being transferred. This means that they are not being shared. They are being donated from one element to a different element. Now, there are several properties that ionic compounds have, such as high melting points, high boiling points. So with your high melting and boiling points, an easy ionic compound to think of is salt, NaCl. So Na, sodium, that is your metal. Chlorine, that is your nonmetal. Now, salt, you normally don't think of salt melting, okay? That's why you can use salt to put out fires. So if you have a fire in your kitchen, something on your burner, on your stove, and it catches on fire, you actually can pour salt on top of it, and that salt will not melt, even in a high temperature such as being in a flame. So anytime you have an ionic compound, it has a very high melting point, has a very high boiling point. Ionic compounds also ionize in water. So let's talk about what ionize means. So if we say that something ionizes, that means it breaks apart and forms ions. So an ion, that is any time an element has a charge, either positive or negative. And we'll talk more about ionization a little bit later in the year. Now, ionic compounds can also conduct electricity. They're usually very, very hard. So salt, think about salt, it's very, very hard in texture. They usually are not flammable, and they also dissolve in water. So dissolve in water, just think they break apart. Now, some examples by formula. We have NaCl. Once again, that's a metal and a nonmetal. We have MgCl2. That is Rhodes salt. Magnesium is your metal. Chlorine is your nonmetal. Bleach, baking soda is an ionic compound. And also stomach acid, your hydrogen chloride. Now, these next two slides are just a review of some different areas of our periodic table that we still need to be familiar with in order to work with our ionic compounds. Now, you still need to be familiar that your group number, the number of your vertical column, tells you your number of valence electrons. And your number of valence electrons are the number of electrons in the outermost shell of an atom. They're the furthest away from the nucleus. So if we are looking at group 1A, they have 1 valence electron. If we are looking at group 2A, they have 2 valence electrons, and so on and so forth as we go across the periodic table. You also still need to be familiar with charges. So what your group number tells you about the charge of an atom. So if we're looking at group 1A has a positive 1 charge. Group 2A has a +2 charge. Group 3A +3. Group 4A plus or -4. Group 5A -3. 6A -2. 7A -1. And all of your noble gases have that charge of 0. Once again, because your noble gases already have 8 valence electrons, they do not need to gain or lose any electrons to get to 8. They already have it. That is why they have the charge of 0. Now, you'll notice that some of your group A elements have positive charges, some of them have negative charges. So, a little review from your very first unit of the year. We talked about a term that we can give a positively charged element, and in turn we can give a negatively charged element. So anytime we have a metal Metals will always have a positive charge, and if you have an atom with a positive charge, it is called a cation. So an easy way to remember this might be, if you really like cats, then having a lot of cats is a positive thing. So cations have a positive charge. Now, if we are looking at a nonmetal, all of the nonmetals for the most part have a negative charge. These are known as anions. So anions, think anti, against. It's a negative thing. So anions have a negative charge. So if we have a metal, that's a positive charge cation. A nonmetal is a negative charge and it is an anion. The only thing that we didn't really talk about in terms of determining an element's charge is if we are looking at a D block element. So these are all of those atoms that are these are all of your group B elements, and these are the ones I did not have you write down a charge for, okay? And that's because your D block elements have multiple charges. They can change, and that, whatever the charge of a D block element is, it depends on what it's bonded to. So for this reason, we have to follow what is called the stock method for determining the D block element's charge. So make more sense the more and more we practice this. So if we're using the stock method, you first have to look at the charge of the atom, your transition metal. Transition metal is the same thing as a D block element. And you must see what the charge of the atom the transition metal is bonded to figure out the charge of the transition metal, okay? This will make more sense as we work through it. So once again, down below are just some different examples. We have iron. You'll see that iron can have a +3 charge. It also can have a +2 charge. So same element, two different charge possibilities. Copper. Copper can have a +1 charge, or it can have a +2 charge. Two different charge possibilities for the same element. And both iron and copper are found in that D block. They are both transition elements. That just means that both of them can have a charge that can change. So let's look at how we name a binary ionic compound. So your naming rules for ionic compounds, they're a little bit different than covalent, but they're pretty similar. So we have a binary ionic compound. Binary ionic compounds only contain two different elements, one metal and one nonmetal. So think your prefix bi, that means two. So anytime you have an ionic compound and it contains two different elements, that means you're going to use the binary system of naming. So when you're naming your ionic compound, you need to always list your metal name first, and you will never put a prefix on it. So this is much easier than covalent. Now, just keep in mind that your metals have a positive charge. So after you list your metal name without a prefix, you will then list the non-metal name. And once again, you will not put a prefix on it, no matter how many non-metal elements you have. Now, your second element listed, that's your non-metal. Its name will end in "ide." This is very similar to covalent bonding. Your endings were always in "ide." Now, the last thing, which will come more into play later on towards the end of this lecture, is that your compound will always be electrically neutral. So this is what makes ionic compounds tricky. So I'm going to have you add something onto your notes. So to help you understand what I mean by saying that your compound is electrically neutral, is that I mean that all of the charges that are on this ionic compound will together equal 0. And this will make more sense as we practice it. But your ionic compounds, they always have an overall charge of 0. Now, if we have an ionic compound that contains a transition metal or a D block element that can have multiple charges, you have to show me what type of charge this transition metal has. So that means that when you are naming an ionic compound that contains a transition element, you have to put the charge number of that transition element in Roman numerals within its name. So for example, we have iron 2 bonded to chlorine. So when you name it, you must show me that this is iron 2. Your Roman numeral number is the same as your charge. So iron has a +2 charge, so I put a Roman numeral 2 after iron in its name. Now, for this second example, we have iron with a +3 charge. It is once again bonded to chlorine. So when you name this, you will write iron without any prefix, but since it has a +3 charge and it is a transition element, you must put 3 in Roman numerals and then write chloride after it. Always make sure that it ends in "ide." Now, I realize that some of you are not super familiar with your Roman numerals, so this next slide has them here listed out for you. So 1I equals 1, II equals 2, III equals 3, and so on and so forth. You will have to have these memorized for your test so you know what to write down to show your charge. So keep that in mind. If you're not good at writing and being able to understand Roman numerals, I might spend a little bit of time looking over these. Now, let's practice a little bit with naming our binary ionic compounds. Once again, binary means there's just 2 different elements bonded together. So, we have one metal, one nonmetal, we have calcium, we have chlorine. So, when you name this, you'll come up with calcium. Once again, no prefix, and you'll have chloride. Once again, no prefix, even though there are 2 of them. For our second naming example, we have magnesium, that is our metal, bonded to phosphorus, which is our nonmetal. You'll write magnesium's name without any prefixes, even though there's 3 of them. And you'll write phosphide, always ending it in "I", once again with no prefixes, even though there are 2 of them. For third example, we have KCl. So K, that is potassium, bonded to chlorine. So your final name will be potassium chloride. Now, if we have an ionic compound that has more than 2 different types of elements bonded together, this is called a ternary ionic compound. So ternary, just think more than 2. So 3 or more different elements are inside of these compounds. So if we have a ternary ionic compound, that means that we have one metal element that is bonded to what is called a polyatomic ion. So you should have a list in front of you of polyatomic ions. And what a polyatomic ion is it is 2 or more non-metal elements that are bonded together. And even though we basically have a covalent compound formed, it's different. And the reason why is because polyatomic ions, it's 2 or more nonmetals bonded together that have a charge. So all of the covalent compounds we worked with last unit, they did not have a charge. Polyatomic ions do. Now, when we are working with polyatomic ions, if you look at your list, you're going to notice that almost every single one has a negative charge. There are a couple exceptions. One of the main exceptions is that of ammonium. So ammonium, its chemical formula is NH4, and ammonium actually has a +1 charge. So you need to keep this in mind as you're working through and writing out your chemical formulas for ionic compounds. Now, when we are looking at polyatomic ions, they each have their own names. So if you look at your list, there's ammonium, there's hydroxide, there's other types, or each one of those polyatomic ions has its own name. So we need to reflect this when we name our overall ternary ionic compound. So your polyatomic ion, since it has its own name, that name for your polyatomic ion will become part of the ionic compound name. That means that your polyatomic ions will not end in "ide." So unlike your binary, every single time you end your ionic compound name, you are never going to end it in "ide" if it contains a polyatomic ion. And how you can tell if it contains a polyatomic ion is if it has 3 or more different elements inside of your ionic compound. Let's work through a couple of examples. So, first one, which of the following is an ionic compound? So go ahead, pause the video for a second, and see if you can figure this out, and then come back and check your answer. Alright, so by this point you should have looked through your different answer choices, trying to figure out which one was ionic, and there is only one of them, that is NaCl. So Na, sodium, that is a metal, chlorine is a nonmetal. So anytime you have a metal and a nonmetal bonded together, that will form an ionic compound. The rest of these, carbon, hydrogen, nitrogen, chlorine, carbon, and oxygen, those are all non-metal elements. So these, B, C, and D, are covalent compounds. Alright, second example, same question. Go ahead, pause the video for a moment, and see if you can determine which of the following is an ionic compound. Alright, so by this point you should have looked through your different examples, and you should have found that CaO, calcium oxide, is your ionic compound. Let's see if this will let me circle it. So your answer for question 2 was D. And that's because calcium is a metal, oxygen is a nonmetal. Anytime you have a metal bonded to a nonmetal, that is an ionic compound. So let's go to our third and fourth questions on this slide. So it asks you to determine the common charge of barium, and also asks you what is the charge of manganese 3. So go ahead, pause the video for a few minutes, see if you can figure out your common charge of both of these elements. Alright, so at this point you should have looked at your periodic table. You should have found that barium is found in group 2A. So that means that barium has a common charge of positive 2. And if we are looking at manganese, manganese is a transition element. That means its charge changes. However, this tells us that we have manganese 3. And your Roman numeral number tells you your charge. So we know that the charge of manganese is a positive 3. And once again, manganese is positive because it is a metal. All metals are cations. All metals have a positive charge. Now, last example slide. I want you to take a moment, see if you can write the name for the following given chemical formulas. So pause the video for a minute, see if you can write them out. Alright, so at this point you should have seen if you can answer these on your own. So for Ca3N2, the correct ionic compound name is calcium, because we are working with the element calcium, and nitride, because we are working with nitrogen. We have calcium and nitrogen. There are 2 different elements. One is a metal, one is a nonmetal, and this is a binary ionic compound. However, the second example is a little bit different. We have sodium, nitrogen, and oxygen. This is a ternary ionic compound. So that means that we have sodium, our metal, bonded to a polyatomic ion. So our naming system is going to be just a little bit different. So since we have sodium, let me go ahead and write that out. And you should have looked at your polyatomic ion list and found NO3. NO3's name is nitrate. So when you are naming a ternary ionic compound, you need to make sure that you do not end your polyatomic name in "ide." It should be exactly the name that you see on your polyatomic ion list. So if NO3 says nitrate on your list, then nitrate should be the name I see in your compound. Now, this last thing I want to talk to you about, it is not in your notes, it's just kind of some extra information, but it will help you to be able to write out your chemical formulas for ionic compounds. And your worksheet you're working through also deals with this concept. So, when you are given the name of ionic compound, you also must write the formula, but it's not as simple for ionic compounds as it is for covalent. So, go ahead and skip forward to this slide. So this slide is just a reminder of your number of valence electrons that surround your elements. So once again, your number of valence electrons corresponds to your group number. So lithium is in group 1A. It has 1 valence electron. Beryllium is in group 2A. It has 2 valence electrons. Boron is in group 3A. It has 3 valence electrons, and so on and so forth as we go across our periodic table. You still have to be familiar with your concept of how many valence electrons that you have. Now, you need to remember that your ionic bonds, they are from the transfer, the giving away of electrons, the donating of electrons. Electrons are not being shared in an ionic bond. So let's make sure that this makes sense. So we have lithium. Lithium is found in group 1A. It has its 1 valence electron. Then we have chlorine. Chlorine is found in group 7A. So it has its 7 valence electrons surrounding it. When this ionic bond forms, you are actually going to have your valence electron that is on lithium be donated, being given to chlorine. Okay? That will form your ionic bond. So you will, in the end, have lithium chloride together. Now, there is one other thing we need to take into account with our ionic bonds, and that's our charges of our elements. So you will notice that lithium has a +1 charge, chlorine has a -1 charge. Those charges will tell us how many atoms we have of each element inside of our compound. And how we do this is by crossing our charges. So let's make sure this makes sense. So we have a -1. You will cross this charge, and it will become the subscript of your metal element. Lithium has a positive charge. It will become the subscript of the element it is bonded to. However, in this case, lithium has a subscript of 1. Chlorine has a subscript of 1. Anytime your subscript, that little number after your element, is 1, you don't have to write it. So your overall compound is LiCl, lithium chloride. Now, let's look at this next example. We have magnesium and we have 2 chlorines. So let's make sure it makes sense why we have to have 2 chlorines bonded. So we have magnesium. It's in group 2A. It has a +2 charge. We have chlorine. It is in group 7A. It has a -1 charge. And we have to make sure that the overall charge of our compound is 0. Right now, we have +2 -1. That does not equal 0. That equals +1. So we will have to add in a second chlorine. However, one way to make this easier is once again to cross those charges. Those charges will become your subscripts. So magnesium, it will have a subscript of 1 from our chlorine. But anytime your subscript is 1, you do not have to write it. However, chlorine has a subscript of 2 from magnesium. So you will give chlorine that 2 subscript. Now, this is the same as saying that we now have 2 chlorines bonded to 1 magnesium. So +2 -1 -1 will now give us that overall charge of 0. If the charge of your compound equals 0, you know that you have written your formula correctly. So let's look at a couple more examples. So in this case, we have sodium bonded to oxygen. Oxygen has a -2 charge. Sodium has a +1 charge. Our -2 The 2 will become the prefix. Our positive 1 will become the subscript of oxygen. However, since we have sodium with a 2 subscript, we'll write that 2, but since oxygen's subscript is 1, you do not write it. So Na2O is your correct formula. Now let's make sure that our charges balance out as well. So this is the same as saying that we have 2 positively charged sodiums being added to a negative 2 charge. Plus 1 equals plus 2, minus 2 equals an overall charge of 0. And this next example, same deal. We have a plus 2 charge for magnesium. We have a minus 3 charge for phosphorus. So 3 will become the subscript of magnesium. 2 will become the subscript of phosphorus, so that our overall charge equals 0, and our formula is Mg3P2. Last example, we have magnesium with a plus 2 charge being bonded to oxygen with a minus 2 charge. So in this case, it's a little bit different, because normally you would just cross your subscripts, which you can do. However, if both of your subscripts can be divided down, you do that. So in this case, we have magnesium 2, oxygen 2. So to get your most condensed formula, you can just divide both of these subscripts by 2, so that MgO is your overall formula. You also could tell that you only need one of each, because your charges are opposites, but equal. So we have plus 2 minus 2 equals 0. So overall, you would only need one of each type of atom. So this is everything that you need to know as far as naming your ionic compounds goes, and being able to write their formulas from a name. So we will have some time in class to practice this, and if you have any questions, let me know.